Yeah, thank you very much for the introduction, and thank you all for coming here and for giving me the opportunity to be here on site to do this talk. And today I'm going to talk about perceived faster Angular application, and especially about the illusion of a performant web application and how you can benefit from optimizing the bootstrapping process, not only from the technical side, but also by checking the user experience. And let me briefly introduce myself again. I'm Cathrin Möller. I'm a principal consultant at TNG, and I do have a background in full-stack web development, while I soon found the passion for the JavaScript side, for the TypeScript side, and then for Angular. And I also love CSS. And my benefit is I get to see lots of different code bases. I have different clients, I have different teams, I have different developers, and I learn from all of them. I do not only have my own pitfalls from the learning curve I can talk about, I also see what my colleagues are doing. And I've seen a lot, but coming to that later. Coming to today's topic, perceived faster Angular applications. Let me briefly recap what is fast and why. So what's perceived as fast is wired to the human brain, to the human perception, and we cannot fight against it. But to understand what we need to achieve to make something appear fast, we might have this time frame as a help. And sometimes we talk about fluid animations. And if we talk about the fluid animations, we usually mean something is running at 60 frames per second. And this would correspond to a time span of 16 milliseconds. In general, we can say up to 100 milliseconds. Everything we see, the human brain cannot distinguish. It's perceived as instantly. So here we are very, very fast. Up to 300 milliseconds, the brain will be able to notice a small delay. So that's our buffer where we can go. Beyond the 300 milliseconds, it will be noticeably, but the user is usually willing up to 1 second to accept the page is still working, there's no problem behind. Above the second, we go into the orange area and then into the red zone. So users nowadays, especially when loading a new page, they don't know. They will be not happy if the page is taking longer than a second and maybe have a mental context switch, thinking about something else. And there's a certain barrier, and some people say it's 3 seconds, some people say it's 5 seconds and beyond. But at a certain point, the user will believe the page is broken, the page is dead, something's not working, and lose interest and give up. A short recap why most enterprise companies use Angular as their JavaScript framework of choice, and why I would recommend it always for most cases in these enterprise companies. Angular, compared to other frameworks like React, Vue, or Svelte, is by definition a full framework. It's an all-in-one package, not only delivering us some UI capabilities, but we have everything from the same team. So we have packages for form validation, we have tooling to do HTTP client requests to the backend, we have our router, we have state management. Everything is standardized. And if we have teams all over the world developing pieces of an Angular application, they usually do not need to communicate so much with each other, because in Angular there are standards for most things. So it's less likely than with other frameworks to end up with a tech stack that's not integratable, that's not fitting together. And also from my experience, especially with people coming new into web development, in Angular it's much easier to get into because the architecture is clear, we have standard patterns, everybody knows where to look for a certain piece of functionality if we even look at a different code base. And just as a reminder, because my clients, they sometimes want to do fancy architecture and do not keep this in background, in order for Angular to have the fastest possible application, you have to respect that it's intended to be a single-page application. And just in case there are some prejudices of some manager liking to want to move from Angular to Vue or Svelte to make your application faster because the bundle size is smaller, yeah, if you count Angular core against Vue on bundle phobia and check the bundle sizes, Angular is bigger. But you are not comparing the same thing. In Angular, you have much larger feature set. You have much more features coming out. And since Ivy compiler, we also can benefit from tree shaking to make unneeded code stripped away. And during runtime, ahead of time compilation also makes the bundle faster. And just from my experience and my colleagues, some of them are working on a bigger Vue project. So if you compare full real-life applications, having everything from routing to state management and so on, in the end, if we sum up all bundles, at the end, we get more or less the same size. So it's not true to bash against Angular and say it's large. But what happens if a bundle size is large? If a page is loading, the JavaScript has to be downloaded, and then it has to be interpreted before it can do anything. And what the user is seeing in that case, what's the fear of many project managers, and for sure not the best user experience, is the user is staring at a blank screen. And even many well-known websites let the user stare at a blank screen for something like 3 seconds on average. So that's not good. But to do anything against it, we have to understand where is this blank screen coming from. And at TNG, we have a joke. We call ourselves TNG testen, nicht glauben. So test it, do not blindly believe. And we want to know what is slow. Is it the front end? Is it the back end? Is it some tech stack? What is slow? And in the front end, we have the Chrome Dev tools that we can learn a lot why our page is slow and which pieces are slow, and do a lot of quick wins in order to optimize our page, which does not need to go directly into Angular. Because, for example, we can realize we have heavy-sized images being downloaded, and they might be compromised and without losing the resolution. Or we have too many requests going on, too many CSS sets of some weird side widget we are injecting, or we have blocking threads. Maybe we can realize from the network it's not even the front end which is to blame, because our initial data that we want to render from the back end is taking so long. So we have a black box backend request which is blocking our page. And furthermore than just doing network analysis, with the Lighthouse report, we have a powerful tool to measure the Google Core Web Vitals, like how long is it taking until we get a meaningful paint, how long until the user can click on the logging button, and so on. And this is giving us upfront a lot of meaningful suggestions what to do, the opportunities to make these key values faster and to improve our performance. So for example, it points out that if a team is using Moment.js for date formatting, there's a smaller alternative, which is Day.js, and we could benefit by sparing a lot of bundle size. But talking about performance and doing all this optimization, from my experience, doing technical optimization is one part. But what might be more relevant to the user is the perceived performance, the user experience, what the user is seeing. And there might be technical limits, especially if we have to deal with a legacy backend system that's deriving us the data, and we cannot go faster. So we have to take care of the perceived performance of the visual part. And also talking about performance, We heard yesterday also a lot about runtime performance. I want you to keep in mind that we have the initial performance, which is the first impression of a user coming to our page the first time, and we have the runtime performance. And we can say if a user is willing to use our website, is already visiting us, it's already clicking around, the user being already engaged is usually much more willing to accept that it's not super fast. So what we should focus on is improving the initial performance. And to understand where is this initial performance coming from and what we can do and what we can avoid, we have to look at step by step what's happening when Angular is bootstrapped. What's happening when we load an application and how are we finally reaching our content. And the 3 files I want you to keep the most interest in are for sure, for first, the index HTML, where all our JavaScript is loaded, and apparently in the end, our content is being projected. Second step is the main TypeScript file, the initial vanilla.js file where our Angular content is bootstrapped. And then, going into Angular content, we start with the app module. And I want to talk about some tricks with the app initializer interface, where we have some options to load something upfront before the app is bootstrapped. But coming to the index HTML, how does it look like? If I just do a normal Angular build, having generated the standard boilerplate, after the build, if we look in the dist folder to our index HTML, it looks like this. So it's more or less empty. We have our app root HTML node, where finally, in the end, our app is going to be projected into. And we have for sure all the JavaScript dependencies and also the style, either in a JavaScript or CSS bundle. And at the very end, there's the main JS file, which is containing the code of our application. And if we just use this boilerplate and don't do anything against it, until our JavaScript is loaded, is interpreted, and all the bootstrapping worked, we see a white screen. So if we go with the standards, we have usually an empty page. And in order to be fast, to deliver the user something, we can go before loading the JavaScript content. So we can place something in our index HTML. In the most simplistic manner, we could use a spinner. And this might help the user if we know all the follow-up steps take a long time. It might let the user know once he's browsing the page, it's not a blank screen, it's not a dead page, the page is alive, we are fetching some data. But the spinner, in its standard concept, has an alternative which is much better and heavily used nowadays from a lot of well-known websites and apps, just as YouTube, Amazon, and so on. And there have been studies on user experience that a shimmer animation, a skeleton, having some shadow elements for the real content to be displayed on the screen, is keeping the user busy for longer. So especially if the animation is going from left to right and has some pulsation, some movement inside, it's keeping the user most attracted and time will fly. And we can gain a lot of time that our backend data might be fetched in order to keep the user interested. And just to give you an example how this might look like, I made a small prototype once for my client, just with pure HTML and CSS. And this is how a shimmer animation might look like with this movement. And we had the problem on a starting page that our backend data really could not go faster than 5 seconds. And just for the user, after the login, coming to the dashboard, this helped to make the user experience much nicer and to have a good-looking page, even though the real technical values behind were still slow. And to give you some idea how it might look like, this is what we can do in a most simplistic manner with our index HTML file. So before the app root node, before the Angular, and before all the JavaScript bundle, we can place some static content. So at the top, we can load the critical CSS for that shimmer animation, and then we have just some static HTML for the skeleton, for the shimmer, that we can remove later on in our application once we fetch the data, once the content is ready. And this is especially helpful for such slow backend data cases. And just looking shortly at the tricks of the CSS, it's really just pure CSS, and everything you see here is what I showed before in the animation. So I have some canvas that stretches across the screen, which is covering all content below, so app root component. And we have some fixed height elements, and the key trick here in CSS is doing some animation. The background is moving, and on top of it, to get this moving sensation, I'm using background gradients to achieve this. After the index HTML file, we come to the main TS file. And before doing any optimization, in my experience, it's sometimes better to avoid certain pitfalls. And it might not only be the developers to blame, it might be some project managers to blame that they want something for our app, which is maybe not needed in the end. They overcomplicate things by forcing us to load some runtime configuration up front. Because our app needs to be configurable, it needs to serve several countries, we want to reuse it. And what I saw from some different team in our project, they loaded the custom configuration for the app root, and they relied on it. They did not want to render any content before we loaded that custom configuration. And if you go into the main TS file and try to load such configuration up front before we bootstrap our app module, you must know it's blocking. Due to the single-threaded nature of JavaScript, it's blocking. So if we do anything like this, we will delay that our app module is going to be bootstrapped. And maybe we need it because this config is really critical, but maybe we don't need it actually to show something first, and we do not want to delay. And there's an easy way out, an easy alternative, that we can just wrap these lines of code loading that configuration in a set timeout wrapper function. What is it doing? It's pushing this event to the event queue. It's now treated asynchronously. And our code at the bottom of the file, which is bootstrapping our application, is still continued to be executed. And maybe if the content we want to load from this global configuration is not critical for the first screen rendering or so, we can place it to some session storage or so to read it later from our application. And we do not need to delay the bootstrapping. But from my experience, in the most recent projects I've been working for, we actually did not need this runtime configuration. Even though managers said, we want this, we found a nicer way. We now have deploy time configuration, which usually fits most of the needs. And we are not using some extra configuration pattern. We rely on more or less a blend of the traditional Angular way of these environment parameters to make the configuration, to switch between some feature flags, showing different content on the dashboard maybe, having different navigation options, different sub-pages in our app, and for sure to configure also where's my backend endpoint I'm talking to. And we have a trick here. We have, in the environment def file, we just have standard local values if we want to run our application locally. But for doing a production build or build on the QA system, on the demo system, we use these placeholders. And be careful, we sometimes had problems with Ivy, with these placeholders, because an expression was evaluated against that. And if I compare if the country equals Germany or so DE as locales, and in the placeholder in building the bundle, it's always __ environment country. This expression might evaluate always to false because we don't know what the content will be. But we found ways against it. And this is really helping our client because the build, the yarn install, the compilation, and so on our build servers, it's usually slow. It takes something in the order of 15 minutes. But our deployment scripts that replace from this Git historized Helm charts the values into our configurable application and replace those placeholders, it's usually running in something like the order of seconds, definitely less than a minute. So this gives us the chance to avoid runtime configuration and go with deploy time configuration, because if I change these values in our Helm charts, I can recreate the application within a minute and have the updated values. Another thing with this runtime blocking concept, I've seen many teams writing code with a runtime localization, maybe due to management requirements, not to technical needs. Or, even worse, due to the fact that teams did not want to write their texts in XLIF files. They hated the XML format, and they did not know that Angular supported now for many years also JSON format to keep our key value pairs for the text. And I always try to avoid having this runtime locales, because in Angular nowadays, if I have my key value pairs in the JSON files for all my locales, I can create bundles for each and every locale all together with one build, and it's usually a few seconds on top per locale, and then I have bundles with hard-coded texts in the respective locale. And this is not only helping us against this blocking concept of loading some localization files, it's also making the page faster because there are no more these translation bindings in our template. There's no need to run change detection for any texts. It's fixed and it's fast. Coming to the third part of the bootstrapping. So here we finally reach the real Angular code. We are in the app module. And we can benefit from this interface, which is app initializer, that we can use to call some methods to do something before our app is finally bootstrapping and loading the app component, projecting content. And this app initializer interface, it has different possible return values. So it can be either void, or it can be something asynchronous, like an observable or promise. And I saw code trying to load upfront some tracking setup. We wanted to inject some tracking JavaScript. We wanted to set up some global window parameters in order to base the tracking with some initial data. And I saw code which was doing this in a promise return value app initializer. And you must know, if we use a promise returned app initializer, it's blocking. And the capability to do something blocking might be relevant in some cases, because maybe we need to do something blocking, like guaranteeing we are authorized to visit our page upfront. But maybe if we want to do something like tracking, it might not need to be blocking. And the alternative would be just to use the void return value. And the void return value still allows us, in the sequence order, to do something very early in our code execution with this app initializer, but we can go on and bootstrap our application, create our app component, render something, while the tracking is completed in the background because it's no longer blocking. Having talked now about the initial performance, I might also talk about a little bit about runtime performance. And from my experience, it's often really not the front end which is to blame. It might depend on the back end. Especially, I worked for several years for a web shop. We have to deal with the pay now situation. So sometimes the pay now button is the slowest piece at runtime in our application because there's so much going on in the background. There's so much happening in the backend. We might not only need to talk to our own backend, but we have to talk to third-party payment providers from outside. And we cannot control how fast they are, how fast they do the security check that our user can use the credit card and the payment will be successful. But the problem is what the user sees, what's perceived in the end, is the backend is slow. I click the button and nothing is happening. And it's dissatisfying for the user. And I found several ways to alleviate the situation a little bit, because sometimes we really cannot optimize the backend, or backend optimization might take several weeks or 1 month, several sprints to achieve something. And the easiest way to do something against it is using the power of CSS animations. And definitely not doing animation via JavaScript, because due to single-threaded nature, this might slow down our code executions. But with CSS, with transitions and animations, we have a powerful tool and we can gain some time. And just a word of warning, there's a nice page, it's csstriggers.com, and it tells us which CSS properties can I animate, so change from one value to another within a given time frame. And due to the critical rendering path, there are certain attributes I can animate safely without losing my fluid experience. And these are opacity, scale, rotation, and transform. You would say scale, so shrinking or increasing something is the same as changing the width and height. No, it's not. In this rendering, width and height would trigger a relayout, a repaint, and a recomposite, while scale is much faster. And to give you an example what we can do now, we have our Pay Now button. We know the backend will need time. We cannot make it faster. So what we can do, we can gain, for example, instantly 300 milliseconds by keeping the user interested in doing a CSS transformation and animation which runs only once by scaling this button with 20%. So the user clicks on it and it grows over 300 milliseconds by 20%. So the user is busy, he knows the page is alive, something is working for at least these 300 milliseconds, which increase the user experience of our page. And we can combine that pattern in some cases. Imagine we have a wish list feature in our web shop. So we can do also some fancy animations which might take longer than 300 milliseconds by, for example, when the user clicks on the heart, making it bigger and smaller and bigger, so changing the size multiple times, and also do some flickering between pink and red and pink and keep the user interested for some time. But in many cases, when the backend is slow, when we might get a late response, maybe in the case like save just a setting to the database for this wishlist entry, we might know in 99% of the cases or even more, this update will work. So the save in the database will happen. So what we can do now here in our front end is do some optimistic update. So we believe it's going to happen, and we will not wait for the post response of our backend and assume it worked and keep the wish list active to let the user know it worked. And some websites use it, like, for example, the like button on Facebook. So this is a common pattern. And another thing I saw in a project is we are having a page with credit cards and user information, and this content was taking a long time, more than 5 seconds, because in the backend, we needed to figure out which credit card was used for which open insurance policy. So it was a really heavy task to find that out. But actually, the information which was the most problematic was this connection to the insurance policies, which I marked here with ... It might not even be visible to the user if I have a placeholder up front, if this data is taking long. And we did a parallel update, loading the most visible content first, and then injecting the additional information for the order or the policies where the credit cards have been used. And we achieved this by having 2 parallel backend calls to get just the payment methods and the payment methods with details. And in our case, it helped us tremendously because we realized in backend, we get after 500 milliseconds all the credit card data, even if the user had 20 credit cards stored, while the contract information was taking 5 seconds. So let me summarize for today. I hope you realized that perceived waiting time is what matters. It's not only the technical part, and it's important to keep, for a nice user experience, the illusion of having a performant web page. And we can do so by using bridging animations, also to cover slow backends. We can use optimistic updates and do some transitions. And please take care of index HTML or some initial content. And we can do so, for example, with these shimmer or skeleton animations. And also, I just recommend, don't always believe the management if the management is wanting some runtime configuration. Think about it twice. And maybe some small things like this might help you getting a much faster page, and then you don't need to over-optimize heavily, technically, the parts later on. So thank you for listening.